Okay, so you want to learn organic chemistry for your JEE or NEET. You've done everything that you can, from writing down reaction mechanisms over and over again to attempting to learn all possible reactions, but things haven't worked out, right? You may be someone who's just not understanding what's exactly happening with the reactions, or you may be someone who just can't visualize the reactions. For all your infinite problems, I have 3 simple solutions. 3 cheat codes to always ace organic chemistry. Let's get going. Throughout this entire video, I'll be pulling up multiple different points. I'll be using my board, I'll be using my screen to highlight some points. So I want you to make important notes of all of the things that I'll be talking about. Alright, let's understand what organic chemistry is going to be all about. So, basics of your grade 11 organic chemistry deals with general organic chemistry. After that, we'll be looking into hydrocarbons and how to apply whatever you're going to be doing in 11th and 12th in your 12th grade. Firstly, let's understand, what is organic chemistry? Is it the study of compounds that are majorly found in living organisms? Yes. Can it also be synthesized outside of living organisms? Yes. Can it naturally be found outside living organisms? Also yes. So why do we call it organic chemistry? It's because organic compounds were first found within living organisms. That's how the name came about. So as I mentioned, grade 11 organic chemistry is all about the basics. You're looking into general organic chemistry. You're looking into how you're going to be studying organic chemistry for the rest of these 2 years. Your general organic chemistry starts with why carbon. Your general organic chemistry starts with why carbon forms organic compounds. Simple answers to that. I suppose you should be knowing this by now. Tetravalency and catenation. After understanding why carbon is responsible for forming the majority of organic compounds, let's understand how to represent these compounds. Here is where your first cheat code comes into the picture. Familiarize yourself with bondline structures and 3D arrangements. This is because you will not find your typical structures of like C and all of your hydrogens all arranged around you. You're very much bound to find more complex structures, something like this maybe. I'm sure you must have come across a benzene ring. What if I attach another aromatic ring to it? I could attach a secondary chain to it as well. I could attach some other group to it as well. So many different ways of doing things, right? To express these heavier compounds, it is not easy to draw every single carbon, every single hydrogen, so we stick to bondline structures. Moreover, 3D arrangements, where you're dealing with your isomers, especially. Say you have something like this, where I have say a hydrogen over here, a hydrogen over here, a chlorine over here, and say a methyl group over here. This arrangement, this flying wedge structure, you'll come across these terms definitely. This flying wedge structure is commonly used to represent 3D structures of particular compounds. To understand reactions, especially when you'll be dealing with your SN1 and SN2 mechanisms in grade 12, you need to understand how these 3D representations work. Then we move on into classification in the nomenclature. When you understand the logic behind those classifications, you'll be able to go through it much better. Isomerism. I have labeled it as the secret killer. There's a reason for it. When you don't understand how isomerism works, it creates troubles. In what sense? Say if I have a reaction and it creates an isomer, how do you know which isomer has been formed? Or when you have multiple different compounds being formed, which may be isomers, How do you understand that? The examples of this you'll be looking into in much more detail in grade 12, but understand the basics now itself. You may not get direct questions from isomerism in your exams, but a lot of twisted questions come up. So be prepared for that. Now, to understand the bulk of your reaction mechanisms, ask why and how. I suggest studying this part of your GOC with hydrocarbons. So do this first, then go to hydrocarbons, the reaction mechanism specifically, and revisit these concepts when you're doing your grade 12 reactions. You'll understand better all of your mechanisms in that manner. So what do we mean by asking questions? This also links to my LAT system, the learn, apply, test system. So this very much comes into your learn phase. How do we go about this? We're going to create a learning loop. This is something I delved into detail in the last video. Link is up in the cards. So let's start by asking questions. I've taken this example over here of this halogenation reaction and this other halogenation reaction. Both of them are halogenation. I am just representing one with an aliphatic carbon and one with an aromatic carbon. However, notice the mechanism differences. Look at the first reaction. I am using heat or light, whereas in the second mechanism I am using a catalyst. I am using FeBr3. So what is the difference? Here I am noticing a homolytic cleavage, where Br2 is breaking homolytically, whereas in your second mechanism here the cleavage is heterolytic. Why is the first example homolytic cleavage and the second one a heterolytic one? Why is a carbocation formed in the second reaction? Why is the aromatic free radical not being formed? Whereas in the first one you see a clear-cut free radical being formed. Why isn't that the case here? Can I perform a free radical halogenation with the aromatic compounds? Is it even possible? Is the attacking reagent on the carbocation over here that you see a nucleophile or an electrophile? Does that mean it's a nucleophilic substitution reaction or an electrophilic substitution reaction? If I'm forming a carbocation, what's the trend when I have a primary versus a secondary versus a tertiary carbon? What's the trend? What is responsible for this trend to be there? And what effect does it have on the rate of reactions? Look at the kind of question that I've asked. There are so many places that I've asked why and how, right? Why is this happening? How is this happening? Ask these questions. That will help you understand organic chemistry extremely well. Chemistry is all about reasoning. So understand the reasons behind it. So in my last video when I talked about learning loop, the amount of questions that you ask, you write that down. You write the answers down. You write your understanding. You write your doubt points and you get them clarified. Write the best answer. Do this over and over again to understand all of your mechanisms, to understand all of these bulk of your reactions that you have with your GOC. Now that we have been asking questions, how do we use this question answer format to understand reactions? Let's break down reactions into logical steps. So here is a simple list of questions that I've made over here. What are the substrates? Why are these substrates used? Can some other substrates work? What are the reagents? What are the catalysts? How are the catalysts working? How are the reagents working? Why are the reagents working in the particular manner that is shown in the mechanism? What are the products formed? Can any other products form? Let's put it into the use case over here that I've shown of the addition reaction on a cycloalkene. I am adding HBr. One product is the Markovnikov product that I am forming and the other is the anti-Markovnikov product. Why are these two compounds different? Here bromine is being attached to this carbon, here the bromine is to this carbon. Why so? What is this Markov-Nikov rule? What is the basis of it? Well, that's kind of answered with the explanation that I just gave. Why is it also called the peroxide effect? How does the peroxide create different attacking sites? See, when you create these questions, you're able to understand the mechanism in detail. So now if I give you a very complex compound, say let's have something like this, a 2-ring structure, and I have, say, something over here. I have a very complicated side chain, and I want to add HBr to this in presence of a peroxide. How does the product get formed? Understand that. Ask your questions, find your answers, get your doubts clear, and of course, use my free printable for it. Use this understanding of reactions for your hydrocarbon chapter when you're going for your preparation reactions, when you're going for other chemical reactions. The rest of your hydrocarbons chapter is logical. Classification, nomenclature, all of it is logical. The bulk is understanding how these reactions work. This is true for the bulk of your 12th grade reactions as well. If you want me to go into detail on each and every topic that you have doubts in, or if you are finding difficult, let me know in the comments and I'll make sure to make a video on that as well. With this, we sign off for today. Till then, all the best, study well, thank you and happy learning.